Okay, then I'm gonna start. So hi guys, I'm Sangbin from Anyscale, and here's my colleague Ricky. We're going to present Ray Observability, present and future. So let me have a brief introduction about ourselves. We are both software engineers at Anyscale. We are working on Ray Core, which is building the Ray Core distributed systems. And our recent focus is to improve the Ray observability that many of you already have complaints. Yeah. And also, we are from Anyscale. Anyscale is a creator of Ray, and we are building scalable compute for AI and Python. Okay, so if you're interested in how to debug Ray application, what tools are actually available for debugging Ray, and what's new in Ray 2.0, and what we are planning to do in the future, then this is the talk you're looking for. And here's the outline. So we're going to start from the requirements in Ray observability, and how it looked like before Ray 2.0, what worked well, what didn't, and the new feature in Ray 2.0. And we're going to have a quick demonstration of all the features. And we're going to finish the presentation with the future roadmap. So let's start from the first section, requirements in Ray observability. So Ray provides APIs to build distributed applications. So this hides the implementation detail of distributed systems and help users to focus on building applications running at scale without understanding distributed systems. Then why is it so hard to difficult Ray? Let's see how Ray actually looks like under the hood. So there's actually a head node in the Ray. When you have a Ray, there's a head node which is managing the whole cluster. And of course, there are a lot of worker nodes that's actually executing your code. And then if you actually have large-scale cluster, this is how it looks like. You're going to have tons of machines there, and there are going to be a lot of Ray tasks, Ray actor, Ray objects, like stored and running concurrently and executed across many different machines. And this is actual distributed benchmark we've done before. So as you can see, we can have like 100 of nodes, like tens of thousands of actors and tasks, and there are like millions of objects. So it's normal, like there are so many things going on in the cluster. And with all this in mind, imagine actually something went wrong, like your application is not fast enough, it hangs or crashes, and like for example, your actor failed, or many of actor failed, and it's like very, very, very frustrating. And then you imagine you have to figure out why this failed. Like by nature, distributed system can have so many different failure models because they have heterogeneous resources, many different machines, more likelihood of failure across them. And there are also a lot of data, as you see, like task actors, objects. So debugging issues in this kind of environment is not trivial. And this requires the system to have a really strong support, like tools and other workflow for you to actually go through to make it debugging easy. So how can we make it still easy with this environment? So in our perspective, there are two important things we need to focus. The first thing is we need to understand the workflow. So what's the typical workflow user face when they're doing debugging? And also, of course, we need to have the right tools to actually help you debugging in this distributed environment. Oh, sorry. So this is the key workflow when you debug your application. So first, you want to have the visibility into your application. So you need to have the monitoring. And then whenever something goes wrong, the error has to surface to you. So there should be the right error, or there should be the way to give the signal that something's going wrong. And of course, you need to have the right tools and data in the system so you can actually debug when something goes wrong. And the right mitigation strategy, and the correct guide for you to fix your issue. And then to support such workflow, there must be corresponding tools for each step. So for example, when you're monitoring, you may want to have a dashboard. That's not as bad as now, but really great one. And also progress report, or like application level logs. Or when you actually surface error, you need to have the right exception models as well as the great error messages. And for when you actually debug, you need to have tools like debugger, or like a profiler, or many other different tools for you to debug Ray application. And we are actually going through how it looked like before 2.0 and what we are good at and what we are not. So I'm going to show two case studies. The first thing is, I think pre-Ray 2.0, the interactive development is really common debugging case. Like you're developing something, like something's broken, you fix it, and like interactively iterate it. And then actual production workload, right? Like your system fail in the middle of your run. And then the first case scenario was actually pretty well supported by Ray before 2.0, and I'd like to go through the tools we have that help you this scenario. So this is a simple toy Ray application. So you create 4 actors, and then you're just calling into all the actors and just getting the result. So pretty typical Ray application. And this is, of course, how it looks like in the real world. You're going to have 4 different actors. And then think about the first step. So you want to monitor your application. And in the interactive development, the most common case is actually writing logs, right? You just write print hello, and then you want this hello to be coming to your script, standard out. And this is actually really well supported in Ray. So Ray has a native support to print logs from task and actors. And by default, all the standard out and standard error from your task and actor, they are basically streamed back to the driver program. So this is the example. So if you have a print haha, as you see from the image, you can actually see haha from your driver. And it shows other metadata, like what's the name of task, what's the PID. And this is a new feature at Ray 2.0, but you also have a Ray log API to access log of actors, tasks, workers, and other system log. So as you can see from here, you just specify the same PID from the driver, and you're actually able to see the same log through the CLI API after a task is over or actor is over. Okay, so now you can monitor your application. The next thing, following our workflow, is how do you surface the error when you do interactive development. And if you use Python, of course, the most common case is getting an exception when something fails. So for example, you have an actor, and there's a print task, and let's say you have division by 0 error like this. Basically, what you want is that you want to get this exception in your main program and throw the right exception. And Ray automatically finds the exception from its remote task and propagate error back to the users. And I'm going to show you how it works. So all the Ray primitives, like a task, object, and actor, they generate the object reference like this. And whenever anything goes wrong, then the generator of the object reference. So for example, in this case, like actor, whenever actor goes wrong, like there's application failure, actor is like all of a sudden killed, all of this information is automatically written to the reference. And when you actually call ray.get, it's going to throw an exception for you. So this is an example. So you can actually see the exception. And whenever there's system failure, you can see like something like this. I think many of you already know this error message. And then now the error is surfaced. Now user wants to debug. And Ray, I'm going to introduce 2 tools. And the first one is the debugger. So debugger is a very common tool when you actually debug application in Python, right? So what you want is you just want to have a breakpoint. It's like equivalent comment as regular Python. And you want to actually debug the program. And Ray has its own distributed debugger to support this case. So when you develop Ray, you want to have like tools like PDB for you to actually get into your code and see the state of your code interactively. And Ray has its own PDB integration to support distributed debugging. So as you can see from here, you can just use exactly the same command, like just add a breakpoint. And in your terminal, you can just call Ray debug. And it's going to give you CLI, something like this. And you're able to actually jump through different task and actor and actually go in there and use PDB in there. And we are going to actually have more detailed demonstration sooner or later. And then lastly, your application might be slower than you think. For example, let's imagine the actor is doing some busy work and returning large objects. And then one of your actors is extremely slow. And you want to figure out why this is slow and others is not. And so this means like sometimes users want to trace low-level per worker, like function-level operation to find the bottlenecks in performance. And this is supported by Ray pre-2.0 as well as a Ray timeline API. So you're able to actually see all the workers, and then each worker you can see how long each operation takes. So in this example, we have a task, and most of task store output took the most of time. And it also shows the duration like this. So like for 85 milliseconds, it was running a task, and out of 85 milliseconds, it was storing the output, meaning the bottleneck is storing the output. So you can figure out what's the exact problem. And of course, it had other tools pre-2.0. For example, we supported metrics and custom metrics, and we have a native integration to Prometheus. So you're able to actually export the metric, emit it from Ray, and create your own Grafana dashboard. And we also have a experimental distributed tracing, which is useful for application like RayServe, which is like service-based application. And also we had a dashboard. And Ray dashboard previously didn't have a lot of features, just shows all the node, all the process, resource usage in a real time. But we're going to show how we're going to improve in the future in the later of this presentation. Okay, so I'm going to take over the talk to Ricky, and he's going to talk about what's new in Ray 2.0.
All right, thanks, Sen. So Sen has given you a kind of overview of what happens before Ray 2.0. So Ray has many tools, as you're saying, but is it sufficient? Well, apparently no, right? Otherwise, I wouldn't be seeing many of you guys here listening to the talk, I guess. So it's good for interactive development, right? So you can start your Ray program, you can see the logs, you can see the tracing, the dashboard. But when it comes to large system, which is usually what Ray was actually useful for, you have like system failures like hanging out of memory issues, right? So at that point of time, it's very hard to debug. And we could actually see some kind of use case for that. So I have the same actor. And instead of 4, what if I have like 30,000 actors running? And then for each actor, I call them like one of the API like 1,000 times, right? So this essentially gives you a Ray program that has like millions of actor tasks running at the same time. And one of them doesn't really do well and go out of memory. And the OS comes in, kills the actor. You will see the error message. All right, so I would be like, okay, wait a minute, like which actor died? I have like 30,000 there, right? Where do I find the log, right? Even if I see the log, like go through the log, like what should I do after seeing the log? So these are the examples that why debugging Ray before might have been difficult. And what's worse is that if you have like 4 running actors, like somehow just didn't get initialized because you don't have that much cluster resources, right? So they get stuck forever, and you don't really know that. You basically have like very little way to actually inspect the actor states, the scheduling states of the actor. So this is what we worked on for Ray 2.0. So we introduced the state API, and also we did a revamp on the Ray exceptions. Right, so let's look at what the state APIs are about. So the state API introduced a couple more APIs that are available both in CLIs and also in Python SDKs, which gives you an overview of like the Ray states such as object, task, and actors, etc. So one of the first group of APIs are the summary API. So the summary API are what you probably use as the entry point for your debugging, right? So you could probably run it with watch every 2 seconds. You could fetch it. This gives you a high overview of your states in the Ray program, right? So see Ray summary tasks, you will see like a bunch of like number of tasks running, what are different tasks with different names, like what states they are in. And once you have like a high overview, then you might want to be like narrowing down to maybe a specific group of tasks or actors or states, right? So you could use the list and get APIs to get information with like filter, and a detail flag. So we'll go through more detail in this, like go through the output of this later in the demo. So this gives you a sense of like how you should be using the API or what API could I potentially do. Cool, so other than objects, tasks, and actors, we also allow you to like query state things like workers, nodes, runtime environments, jobs, and placement groups. So we hope this will be the first step for us to bridge the gap between detecting what state your current Ray program is. So hopefully make debugging a little bit easier for you on the Ray cluster. And another thing that we worked on is we kind of revamped the Ray exceptions. The idea here is to give the users as much information as possible when something goes wrong, then throw an exception. Right? So our old friend, like out of memory issue, instead of seeing the previous log that I didn't really know how to debug, we actually included information such as like actor ID when actor died, the node that actor is running on, the PID of the worker that's running the actor, and also the worker access status, right? So some potential reasons of why this might have happened and where you could actually start debugging from. All right, so all the screenshots you have saying are cool, but we want to give you a real sense of how this works. So we'll be doing a demo that's stitching together some of the tools together. And in the demo, we'll be using a simple Ray program called website tracker actor. So it's just like a toy actor which takes in a bunch of one-dimensional integer array. You could think them as data points for web page viewing, right? And then the actor will spit out like percentage information, like just does some dummy computation on it. Yeah, I will pass the mic to the meeting last week. Let's do some time travel here.
Let's get into the demo. So I'm currently in a UI developed by Anyscale. So it has a ray cluster attached to it. And I could use raylist nodes to see how many nodes I have in the cluster. As you can see here, it prints out the node ID, the IP, the state of each node, and also a short summary of the resources each node. So I have 2 nodes with 1 GPU each, and another node with 8 CPUs. I could run my web tracker demo script over here in another terminal. So as you can see here, it connects to a ray running cluster, and my website tracker actor is now up and running. So I can navigate to my another terminal, and I will open up another IPython notebook. And in this notebook, I will connect to the running ray cluster as well, and retrieve the actor by its name, my tracker. So I could add a few sessions of website data to the actor by calling the addSessions function on the actor. As you can see, 1 page of session data is loaded, and I could also get the percentile information from the data I just added. So now I have a running ray program and also have a ray running cluster. We could use the ray state API to see the internal states of the cluster. So one of the subcommands of the ray state APIs is ray summary. So I can use ray summary actor. So this will give me an overview of the actor because I only have 1 website tracker actor alive, so it doesn't really print out much information. I could use the list actor API to drill down. So ray list actors will give me the actor ID, its name, its death cause if it has already died, whether it's a detached actor, and the PID of the process that's running the actor, and also the serialized runtime environment that I passed to the actor when I initialized it. The ray state API also supports basic filtering, so I could do ray list workers with the -f flag to see all the alive workers. So as you can see here, I have 2 drivers, which corresponds to the 2 panels on top. And I have a worker, which is actually my website tracker actor that's currently running. You see the matching PID here and here. You can also query the different states in Ray, such as runtime environments, placement groups, jobs. In the interest of time, I will not go through them here. Another group of commands is the Ray logs API. So you could get all the logs on the head node by typing ray logs. So as you can see, the logs that are available are grouped under different categories. There's log from the driver, there's a log from the GCS server, there's log from Reddit, and also logs from different workers. You can see the logs from a particular file by providing a file handle, such as ray logs Python call driver, and with the following flag or an optional tail flag. One of the handy tricks of ray logs is you could use the PID of your actor or the actor ID to directly narrow down to a specific actor's logs. For example, I have my PID here, I can do ray logs, PID, my website tracker's PID, and I will get the logs from the actor directly. So all the APIs I talked about from the command line are also available in the Python SDK. You could import the Python SDK API and then call the functions over there. So this allows the Ray developers to build their own observability stack on top of the Ray State API. Other than the CLIs and the Python SDKs, Ray also has a built-in dashboard that's really useful for high-level information of the cluster. So we can navigate to the dashboard As you can see here, it has a nice table view of the different nodes, the actor that's running on the different nodes. And it also has a short overview of the memory resources and disk resources. So you could use the dashboard UI to navigate through the logs as well. So it provides a nice web interface for you to narrow down into these different logs. It also provides basic searching and filtering and time window selections. Now let's get back to our terminal, and I will try to simulate some failures and show you how this will come up in Ray and potentially how you could debug this. So I have a code snippet over here that I just copy pasted into my terminal. So what it does is basically it goes in a loop, then keep adding data to my website tracker until the point that it wounds. And I could also have the monitoring using the state API to see the current states of my actor. So as you can see, I have the actor running and still alive. As I kick off my small routine, this will keep adding more data into the actor until it wounds. So here you go. You see an error message that pops up telling me that the actor has died. And you also see the release actors shows the error message of the actor exiting. So it says the actor is dead because its worker process has died, and it gives you a couple of reasons or suggestions of why this could potentially happen. So we could use the Ray state API that I just covered to drill down the root cause. But sometimes getting a snapshot of the system when the error happens is just not enough. And what might be more useful here is time series data that potentially reveals trends or signals that might be useful to indicate the root cause of an issue. So Ray has time series data exported, and the users could build their own dashboard on top of those time series data. For example, the AnyScale web UI has a Grafana dashboard that's built in. And let's navigate to the Grafana dashboard. So as you can see here, the dashboard gives me an overview of the cluster, the number of active nodes, and for each type. It also has a summary of the resources usage, and a few more other detailed information such as the object store, the CPU usage and GPU count, the node memory, the GPU memory, and network speed. So Ray supports more time series data than the dashboards over here. And users of Ray could build their own dashboards with customized charts and time series based on their use cases. So for our simple script, we could see that one of the interesting patterns here is the memory spike. So this is a useful signal to indicate that some part of the system runs out of memory. So the Grafana dashboard is useful to observe the trends and high-level information of a running Ray cluster. And sometimes Ray programmers and users will have to dive deeper into their Ray program to understand what might have happened. So Ray has a debugger that I will now show you how to use it. So now let's get back to our terminal. And I have a debug script over here for demoing the usage of debugger. In the script, as you can see, I have a breakpoint at the add sessions function of the website tracker actor. And if I run this script, this will connect to a running Ray program, and it should stop at the breakpoint. And it will spin up a remote PDB session for you to be able to connect to. So in my another terminal, I could type Ray debug. And now I see the list of breakpoints that I could stop at. So if I get into the first breakpoint, and I'm in the add sessions function. So you could use all the PDB commands to look around. And if I hit continue, it will wait for the main program to reach the next breakpoint. Now I'm at the same breakpoint in the second iterations. And I could go into the breakpoint again and incrementally control how the program is run. So with this marks the end of the demo. There are many more other toolings that we didn't have enough time to cover. So please go to the website for documentation, and we look forward to your feedback. Thank you.
Cool. Now let's time travel to now. All right, so I talk about the future of what happens after Ray 2.0 release. So one thing that we know that we're definitely going to work on is the progress report. So this gives you a better view of like how far you are in your Ray job or your Ray program, right? So how many tasks have finished, how long each task has been running. So we might work with the UI team to come up with a better UIs, so you could see this. So all these are prototypes so far, but they will come true one day, hopefully in a couple of months. And the second thing is the events, right? So events are state transition in your Ray programs, right? For example, when a node joins, when a node terminates, or a task finished, or a task failed, you might want to get like chronological view of all those events coming up in your Ray program. So that could give you a better sense of like how or what kind of things the Ray program is doing in your cluster. And the third thing is better performance profiling. Right, so we will be doing better UI for sure, as you can see here. And we will do like memory profiling on top of the CPU profiling we currently support it. And there will be better like per worker profiling for you to drill down into the individual worker's performance. And last but not least, the better dashboard. Right? So I've been talking to many of you guys in the past 2 days. The dashboard definitely needs some love. We actually had a team is wrapping up the UI and the user study. So we have like prototypes that adds in more dashboards and charts into the existing dashboard. And we might also be doing some architecture changes to the dashboard so that it will be more reliable and scalable. So this will be one of our top priority moving forward. And stay tuned for this. So in conclusion, before Ray 2.0, Ray has some toolings that's suitable for interactive development, but there is still a gap between production debugging experiences for users. So we recognize, and we also want to make the first step, or one of the initial steps to bring state APIs to bridge the gap to make it better. And of course, we know there's a long way to go from here, and greater observability will always be the top priority for the Ray team, and we will continue working on that in the next few months. And of course, this could not be achieved without users' feedback. So please take out your phone and scan the QR code and join our Slack channel and tell us what your problems you run into, what thoughts you have in terms of better observability. And thanks to everyone for sticking with us. Do we have time for a couple more questions or? Okay, so maybe 2 more minutes. Yeah, so if anyone has questions, feel free to shoot. If not, we'll be staying around for a couple of minutes on the stage. All right, I guess that's it. Thanks everyone for. Oh, sorry, there's a question. Yes.
UI tracking. Sorry. You were talking about job completion UI. Are there any plans to integrate that with like, what's it called, Ray workflow?
That's a great question. So the question is whether we will be integrating that with Ray workflow.
Yeah, I think eventually we want to help other libraries to build their own like UI and stuff using all this low-level like API. So like as you can see, you can group the task and actors and display to the UI. And I think workflow, I think it depends on like the priority of workflow team, like if they trying to prioritize it. But the goal from us is to basically make the fundamental API for any library to build on top of, so they can actually implement their own progress bar and display on the dashboard, something like that, yeah.
Yeah. All right, so is there another question over there? Over there.
Thank you, Thomas.
That was pretty awesome, all the debugging tools with the Ray CLI. Does that work if we're using KubeRay?
Well, I think it should work when you use KubeRay. Yeah,
Okay,
it's
cool.
yeah.
All right, good to hear.
Yes, over there.
The metrics that you were showing in Grafana there, has there been some thought put into like good, easy ways to programmatically correlate that to the actual workloads that we're running? Like, okay, we saw a memory spike, what tasks were running when that memory spike occurred, like, and kind of programmatically get that information.
Yeah, definitely. I think that comes up in one of like brainstorm sessions for what to do next. So something like Ray Doctor, kind of like, or advisories or whatsoever. But basically, as what you described, I think we are still kind of building infrastructure for those data sources and improving the dashboard, like the Grafana thing, and also potentially correlate that will be a feature that we support. Yeah, but that's definitely a great idea to have.
And also, you're saying adding like a job or like function name on the metrics. Is it correct?
Yeah, I mean, when you export them in Prometheus, I guess being able to tag in some way, I mean, obviously the memory pressure is at like the node level, but if you could at least like tag it in some way to know what was running around this time or something like that.
Right. Yeah, I think definitely we want to support that. I think there's like a cardinality problem in metrics usually, like when you have like so many different tasks. If you like track each individual task, it might like have too high cardinality. But I think what we are thinking is we want to allow you to do that, but maybe you should be able to like turn it on and off depending on your use case. Yeah.
Yeah. I think we should just like pass the high-level application tag into the lower-level metric exporting, so that the metrics will have those like high-level jobs information. Good idea. Sorry, I guess we run out of time, but we'll be like sticking around for a couple more minutes. And thanks everyone for coming in and staying late for until this time. And hope to see you at the next summit. Thank you.